In this video, we'll take a look at insertion operation on arrays. So suppose we want to insert the number -20 into this array at index 3. Then how would we do this? So first we will have to shift all the elements to the right of index 3, including the element at index 3, so that we can make space for the new element, which is -20, to be inserted at index 3. So now let's take a look at it. Look at the scenario. So we will have to shift 21 to location 7, 13 to index 6, 11 to index 5, and 9 to index 4. And we will insert -20 at index 3. So if we look at this operation, how long did it take us? So in the worst case scenario, we just looked at the scenario where we would insert a new element at the middle of the array. What if we were planning to insert an element at the start of the array over here, for example? Then we would pretty much have to shift all of the elements to the right so that we could make space for the new element to be inserted. So that's pretty much shifting almost n elements, right? So that the time complexity of insertion for arrays is big O of n, where n equals the number of elements in the array. So that is basically how we are determining what's the time complexity. That's insertion at the beginning or the middle but as we approach the end, suppose our original array was just like this and we wanted to insert 21 at index 7, then it would take constant time because we already have the space available. We just have to go and insert 21 at index 7, because we know accessing a particular index within an array takes constant time. So insertion at the end of the array takes constant time. Big O of 1 is what is used to represent constant time. So that is assuming that there is enough space within the array already. Suppose our array was full and we wanted to insert 35 at the end, right? Suppose we wanted to insert 35 at the end. Then we would have to basically, resize the array, like take a new segment of the memory which can hold more elements. So now we have 8 elements, right? So we could pretty much take another segment of memory to hold 12 elements and copy each element over and insert the new element, which is 35 at index 8. We will take a look at this example in another video where we'll talk about dynamic arrays. But for now, we won't look at that example. So that's insertion in brief on arrays.